Where? See him? He's sitting down. Hey!
Can we borrow that camera? What do you want to record? In a couple days?
We have to record a commercial for class. It's Dane's.
Dane?
Dane, can we borrow it? We have to film a commercial for class.
Screw that. Right now or just
no, during fourth period.
Don't take me. Yeah. Just be careful with it again.
Yeah. You know? Hey guys, want me to tell the Spencer story about the ice cream?
Yes, we do.
Okay, but I'm gonna do it as if I'm Spencer.
Because he was a witness.
Okay.
Wait, if you can actually do it, can we do it in the hall?
Yeah, let's do it in the hall. You should get a view of me from further back. It looks better like that. Because really up close, I look uglier up close.
It doesn't matter, we'll just do it. Okay, let's do it. What is that clock?
Okay, so guys, one time in 4th grade, I got an ice cream cone, and I was eating my ice cream, and then I went to music class, and the mean teacher said I had to get rid of my ice cream. She made me throw it away in the garbage, and so I cried.
Did you see him at prom?
I did.
You gotta flip
I'm coming back because there's another one.
You missed. I think get
You gotta flip the desk up for protection.
I'm back.
I'm getting really into this. Brandon, you pervert.
P-O-W, yeah. Camp.
Have a couple minutes to get settled down. Let's go to the library. Are you guys going to go sit in there and be super social? No, I hate her.
Spencer, move.
She ruined everything.
That's the soldier's plane, you know.
Sit in the back of this because that's
Linux, because it's stable, it's not stupid friendly, and it's stable.
Is this true, Spencer?
No,
He said it
twice a day.
He said every day freshman year.
I'd be lying then if I did.
The
Fuck!
On camera.
Oh, that was bad.
Yeah.
You want number 4? It's already been taken. You can get number 3 though.
In the wild, he doesn't move at all.
Oh no.
Stationary.
Hey friend. What are you playing?
What are you playing, Casey?
PS2.
Nice.
What game?
Maverick Hunter X. What do you want?
Well, do you remember me from grade school, Casey?
Not really.
Not really. Is there anything you want to say to the camera?
I don't know. Not exactly.
You sure?
I don't know. Stay away from drugs. I don't know.
Yeah, dude.
Are you really good at that game?
Yeah. Beat it a couple of times.
Cool.
What? Oh, you want to see it or something?
Nice.
Yeah.
Alright, see you around, dude.
Yes.
Crap. Don't put this on MySpace.
Yeah, you could be.
That empty space isn't in the slightest bit empty, but is in fact seething with activity, has been observed time and time again in laboratories. And what's wonderful about the proof that emptiness isn't empty is that the first clue came from a jar of mayonnaise. In 1948, a physicist called Hendrik Casimir was the universe we've never noticed before. That's because instead of his equation having one answer, it has two. The first describes the universe we know, made of the atoms we're familiar with. The second describes a kind of mirror image to our universe, made of atoms whose properties are somehow reversed. Now, science fiction fans will know what's coming. as well as matter, Dirac's equation predicts the existence of antimatter. Dirac's theory seemed to say that for everything in our known world, for every part of an atom, every particle, there can exist a corresponding antiparticle, with the same mass, but exactly opposite in every other way. And just like a world in a mirror, a universe made of antimatter atoms would look and work just like ours. It would be perfectly possible for me to be made entirely out of antimatter. Anti-me would look and behave exactly the same as the original me. And indeed it's possible that out there in the vast expanse of the cosmos, there are stars and planets and even living beings made out of antimatter. And there's one final prediction of the Dirac equation. As its punchline, it states that matter and antimatter must never come into contact. Because if they do, they will annihilate each other in a fierce conflagration of pure energy. The combined mass of matter and antimatter would convert completely into energy, according to Einstein's famous equation, E=mc². So, if I ever do meet my doppelganger, we would explode with an energy equivalent to 1,000,000 Hiroshima-sized atom bombs. All this sounds like science fiction. And indeed, the idea of antimatter has inspired huge swathes of it. But the truth is, antimatter, particularly antimatter electrons called positrons, are made routinely now in laboratories. Positrons are used in sophisticated medical imaging devices called PET scanners that can see through our skulls and accurately map pictures of our brains. But back in the 1920s, the initial reaction to Dirac's equation among physicists was deeply skeptical. Even Dirac himself had trouble believing his own results. Antimatter seemed such a preposterous concept. Then came resounding confirmation of the Dirac equation and all its paradoxical implications. And it came from the most unexpected place, outer space. In 1932, physicist Carl Anderson was working here at Caltech in Los Angeles when he made an amazing discovery. He'd been studying cosmic rays. These are high-energy subatomic particles that continuously bombard the Earth from outer space. To do this, he used a device called a cloud chamber. This is basically a vessel that's filled with a fine mist of water vapor. This shows up the tracks of the particles as they stream down through the vapor. And placed inside a magnetic field, these tracks will be deflected one way or the other, depending on the electric charge of the particle. So positive particles tracked then one way, negative the other. Anderson found evidence of particles that look exactly like electrons, but which are deflected in the opposite direction. He had discovered Dirac's anti-electrons, particles of antimatter. The Dirac equation is an impressive achievement. Its prediction of the existence of antimatter using abstract mathematics alone would be enough to make it a significant milestone in the history of human